If you want to master AI agents, you often have to piece together information scattered across a dozen places. A single intensive course might have lecture slides in a PDF, coding exercises in a Kaggle notebook, and critical troubleshooting steps buried in a Discord chat. The standard engineering approach to this problem is to take all those unstructured files and dump them into a vector database. This is a system that translates text into numerical coordinates, so an AI can mathematically search through them. But that creates a black box. The AI can instantly retrieve the data by calculating distances between those numbers, but a human developer cannot easily read, verify, or track changes in that numerical space. The underlying knowledge becomes invisible to the people who actually need to manage it. To fix this gap between machine search and human readability, we can use the Open Knowledge Format, or OKF. It's a standard designed to structure information so that both you and the AI read exactly the same file. A reliable AI education tool requires a foundational knowledge structure that is entirely transparent. By keeping the curriculum in plain text, you can track every edit and update it using the same version control systems developers already use for writing source code. Before the AI can teach the material, we have to extract it from the original files. This happens through a multi-format Python-based command line ingestion pipeline. This sequence diagram shows how the pipeline recursively handles nested files. It reads raw text and sends it to the Gemini model. Gemini enforces a strict pydantic JSON schema, ensuring the AI returns predictable categories, like titles and tags, before generating final markdown files. By using a programmatic script to parse the files, we turn an unpredictable pile of documents into a highly reliable local database, capturing the exact context of the original materials without the noise. Once the files are processed, they become OKF documents. These files have a dual nature, half structured metadata and half unstructured prose. This OKF document code shows the YAML front matter block at the top, containing exact fields like concept type and tags for AI filtering. Below it is the standard markdown text. This freeform section contains human-readable prose, active links, and code examples. Because this is just a plain text directory, there is zero vendor lock-in. No proprietary API is needed to access your curriculum. You can zip it up, host it anywhere, and curate it using standard Git version control. While plain text files are perfect for storage and machine reading, humans learn better by seeing how concepts connect. This visualization shows the force-directed knowledge graph generated from the OKF bundle. Every single file becomes a node in a high-density network, and the sidebar groups them into color-coded communities based on their subject matter. Whenever the ingestion pipeline adds new files to the directory, this visualizer dynamically updates its layout. If a student gets lost in the network, the layout centers itself to instantly provide orientation. A visual map takes a massive static syllabus and turns it into an interactive landscape, allowing a learner to explore relationships between topics rather than just reading a list. This architecture diagram maps the web interface to the knowledge base. On the right, the Google Agent Development Kit powers the Tutor agent. To connect them, the system uses the ATUI protocol, streaming JSON markers like ATUI start over WebSockets to trigger real-time visual events. This interface shows the final user experience. On the left, the agent answers a question in the chat. As it does, it dynamically renders concept cards and sends commands to automatically highlight the corresponding nodes in the graph window on the right. A standard chatbot just outputs text. This bidirectional communication turns the agent into an active concierge that physically points to the curriculum as it teaches. The interface also shifts administrative power directly to the user by integrating slash commands right into the chat box. You can type commands like /ingest or /rebuild. Typing those commands triggers the backend agent workflows. If you drop a new PDF into the folder, you can instruct the agent to clean the database, reparse the files, and update the graph without ever leaving your browser. By engineering a direct bridge between human-readable data structures and autonomous agent workflows, the system keeps the entire curriculum accurate and accessible. Effective knowledge management doesn't require locking your data away in a proprietary database. By keeping the underlying files open and readable, the human student and the AI tutor are always operating on the exact same page.